Today topic is bending of beam. Bending of beam. What is beam? First, what is beam? A horizontal structural member. Structural member which carries transverse load. Next, what is bending? It is the process cause of force or movement. Force or moment. Next, there are two beam. One is straight beam. One is straight beam, and another is curved beam. Both are different based on curvature. It is denoted by K. Second one is radius of curvature. Radius of curvature. Radius of curvature denoted by R. Now discuss about straight beam and curved beam. For straight beam, the straight beam, first this is axis, this straight beam. Draw normal any 2 points and draw this is N1, this is N2, and in this case the normal and intersect at infinite intersection of, so we can say intersection of N1, normal N1, normal N2 at infinite. For straight beam. So we can say the radius of this curvature is infinite and the curvature is zero. Curvature. And for curved beam, this is curved beam. This is curved beam. This is the axis, and any 2 points, take any 2 points on the axis and draw normal and join them, and they intersect at point O. So there is radius curvature is a finite value. This is radius of curvature. So for curve beam, this is straight beam, this is curve beam. So radius of curvature is decrease, curvature will increase. So there is a relation curvature equal to 1 by r. So understand, this is the difference between straight beam and curve beam. Curve beam. Now this is a cantilever beam. Cantilever beam, and here a eccentric loads P at tensile in nature, and this is longitudinal axis, this is LA, and another P loads at the bottom fiber of the beam, compressive in nature, and the height of the beam is H. This is height of the beam is H. Now I am discussing about how to develop moments. There is a point C, and the height, this is H by 2, this is also H by 2, and this is point C. Now I draw here, you can easily understand, and this both P load, and this is C points, this is P, and here P. This P loads transfer at C points. At C points, this is point C, and we know this is H by 2, this is also H by 2. Here is a direct force and a moments. This is P into H by 2, and here this load is transferred at point C. This is compressive, and this is clockwise sense moments, P into distance H by 2, and this P, this is P also, this P and this P both are opposite in nature, so these are cancel out, and this is equivalent, and the equivalence, this and these two moments at, so point, this is point C, at point C there is a moments or couple generate at these two moments H PH. So moment equal to, this moment is called bending moments. So this is clockwise sense, anti-clockwise sense, sorry, this both have clockwise sense, this moment is clockwise sense. Now the definition of bending couple or bending moments. Bending moments or bending couple. Bending couple. A couple is said to be bending couple a, is bending couple bending couple the plane of the this is cross section, this is 2D. Suppose 3D, I draw this beam in 3D 3D. This is 3D, and this is cross section. Suppose this is cross section, and the moment is this, and there also moments generates m equal to p into h from at about point C. This are and this beam is bends. Now this is cross section, this is cross section area, cross sectional area. So plane of when the plane of couple perpendicular to the plane of cross section or this is longitudinal axis or parallel to the longitudinal axis. Understand? Now, how to develop by induce bending stress? When a beam subjected to bending moments or bending moments or bending couple, this also pure bending to internal molecules of beam offers resistance against this couple or these moments. There will be a develop or induce. There will be an induce indirect normal stress This is called bending stress. This bending stress acts normal to the cross section. Suppose this is beam. After bending moments, applying bending moments, this bends, and you can see this is, and this neutral axis is called this and longitudinal axis is called neutral axis. What is neutral axis? What is neutral? This is called neutral axis. What is neutral axis? Is the axis where strain is 0, is the axis where strain or deformation is 0, and also bending stress is 0. This is called neutral axis. This is neutral axis, and above the neutral axis, here this is fiber. This one infinite of number of fiber. This is neutral. This is also fiber above and below the neutral axis. These fibers are in tension. Tension means try to elongate. Fibers in tension, big tension above neutral axis, and this fiber is easily this elongates, and this is compressed. This one is compressed, and compression. And that's why there will the bending stress is above the neutral axis and below the difference, and this one is because this one is above fibers are in tension above the neutral axis in tension, because this force P1 is, this one is eccentric force. This is eccentric, not centric, at not C point. This is eccentric, and you can understand this P is tensile in nature, and the fiber also in tension, and this P is compression, and these fibers are in compression. And here a bending resistance will also bending moments resisting bending moments will develop. bending, resisting bending, resisting bending moment will develop, and this bending applied by the material due to these resisting moments, here bending stress will develop. Now go to the next theory of bending. Theory of bending. Theory of bending. There are some assumptions. Number one, beam is initially straight. Number two, material of beam is homogeneous and isotropic. Homogeneous means this is the points, and elastic constant is constant at a particular points. Elastic constant. This is the body. This is E1, E2, E2, E1. All direction. This is homogeneous. E2 at a particular points. And isotropic means isotropic means at the elastic properties are same at a particular direction. E1 at a particular direction, E2, E3 same, but at a same E1, E2 for different